Hey everybody, Jason McCann with Mountain Tactical Company. There is very few things more satisfying than putting together your own semi-custom rifle. You take your favorite action, you have a custom stock, you have some custom Mountain Tactical components, you have a pre-fit barrel, you put everything together and you can't wait to get this to the range, but of course, you're gonna function test it. And that's what I did with this particular rifle. And then all of a sudden, one of the most satisfying things became one of the most frustrating things. And that's what we're going to talk about today. So I was really hoping to debut this rifle in a completely different video. This rifle is inspired by our New Zealand customers. So our New Zealand customers and a lot of our European customers make fun of us because here in the US, we have these huge rifles. And they have these nice svelte rifles that are short barreled. This is 17 inches, lightweight, accurate hunting rifles set up to hunt out to 600 yards. And they call them bush pigs. And so I was going to debut this as our, hey, Mountain Tactical bush pig rifle. We'll talk about the details of this rifle later, but when I was function testing it to get it ready to go to the range and sight it in, I noticed this. The magazine's spongy. And we've talked about bottom metal and ad nauseum in previous videos. And so went through the normal bottom metal function test, because you always start with the simplest solution and then work your way to the more complicated solution. That's essentially what gunsmiths do. They just have more experience dealing with the different problems. So the first thing I did is I took our billet magazine out. I put a factory magazine in, and we still had this sponginess in here. And I knew the bottom metal was set up correctly, and that wasn't the issue. And when we dove into this rifle, we figured out that it was the stock inlet. Now, this is rather frustrating, and anybody who's been in this position where they got everything together and it's not working, it becomes a really maddening experience. And we should realize that it's not surprising that we have a stock inlet issue. Actually, the most complicated component out of this entire build, and subsequently usually the most expensive, is this really nice carbon fiber stock that I had purchased just for this build. So in my mind, I think that the most expensive piece that I purchased is the problem. This really didn't sit well. But we're going to go over all the dimensions, how to diagnose this problem. And so when you experience this, you know exactly what to look for. So let's dive in to what this stock should be. To diagnose the stock inlet issue, you need a good set of measuring tools. Today, we're going to be using some Mitutoyo digital calipers. Mitutoyo, top notch. Just, if you're going to be doing precision rifle builds, invest the money into good measuring tools. You will save yourself a lot of headaches. Now, we are going to be talking about everything today in metric. And the reason why is because the rifle is designed in Finland with metric dimensions. So, Colin's going to be nice enough to put the metric dimensions in the video, and then he's going to have the imperial translation under that. So, you can follow along whether you're outside of the US or inside the US. So, the very first thing we're going to measure is our bottom metal. And the reason why we're going to measure our bottom metal is there is one thing that I had not included in the bottom metal troubleshooting videos, and that is the critical dimension on here. As far as your bottom metal goes and how it functions in the stock, all the magic is up front. And so while these dimensions are critical, they're not as critical as the thickness of the front of this bottom metal. So the Tikka tolerance is 7 millimeters plus 0.2 millimeters minus 0.1 millimeters. And so I can measure this. These are digital, so I can easily convert it. And the thickness of my bottom metal is 7.1 millimeters, so we're definitely within tolerance. So I've ruled out, with my other troubleshooting, this is not a bottom metal issue. set that to the side. The next thing I want to measure is the height of my recoil lug compared to this flat right here. Let me grab a little pointy device. So we have this flat, this is where the action sits. This is where your recoil lug sits. And if the recoil lug is not sitting deep enough in the stock, it's actually going to push the action up. And the distance between your bottom metal and the bottom of your action is going to be too far. So what is that dimension? We need this to be less than 2.4 millimeters. And we are at 2.3 millimeters. So this recoil lug is sitting at the correct depth. If this was sitting higher than 2.4 millimeters, it's pushing your action up in the stock. The next dimension we want to measure is actually a little more difficult to get, and that is the distance between the flat where your action sits and the bottom where your bottom metal interfaces with the stock. The reason why this is a difficult dimension to measure is there is a 3-degree angle here compared to the surface where your action actually touches. And so there is a critical dimension though where you can actually touch the stock here, and the factory tolerance is 23.6 millimeters. Now there is another critical dimension to measure here, and especially if your aftermarket stock manufacturer doesn't give you this flat here. There are aftermarket stock manufacturers that just eliminate this flat completely. We'll have another video discussing inlet issues. We won't name any manufacturers, but we'll show the different challenges that occur when manufacturers take shortcuts. This flat right here is actually one of the reasons why Tikkas are accurate. It keeps the action from twisting when you pull the trigger. And we need to measure from where the action interfaces where this front action screw hole is to where your bottom metal interfaces with the action. So to do this, we're going to make sure that the action is installed in the stock correctly. We're going to make sure that we are sitting correctly in the recoil lug. Otherwise, we are going to get a false measurement. And we're going to take the depth portion of our micrometer and touch the action dead center in that hole and measure this dimension. This should be 22.2 millimeters plus or minus 0.1 millimeters. And we can see on this particular stock, we are at 22.3 millimeters. So being a factory stock, it's in spec, we would expect to see this. So let's take everything we just went over and let's diagnose what's going on with the stock on our Tikka bush pig. All right, taking the barreled action out of the stock, we're just gonna go through the exact same process and identify what's going on with this particular stock. So take the bottom metal, 7 millimeters, plus 0.2 minus 0.1 millimeters, we're at 6.95, so definitely within that tolerance. The next dimension I'm going to measure is my recoil lug protrusion. So I want this to be less than 2.4 millimeters, and I'm at 2.2. Take another measurement. You always want to take the measurement 3 times and average the 3. So that was 2.17. 2.17. So we're definitely good for the simple things that we could use to diagnose the problem. Let's dive a little deeper. Okay, so next I want to measure the thickness of this interface here. I'm going to make sure I'm nice and flat. Where the action interfaces come in here. And I'm getting a measurement of about 24 millimeters. It's too thick. Tikka spec, 23.6 millimeters, plus or minus 1 millimeter. So we've definitely identified the problem here. Now, I'm going to measure it one other way just because. So I'm going to put the barreled action back in the stock. Make sure there's some downward pressure here so it's not moving. And I want to know what the distance is from the action to this surface. And I'm getting 22.9 millimeters. It's supposed to be 22.2 millimeters, plus or minus 0.1 millimeters. So we've definitely identified the problem and why we're getting the sponginess with our magazine and why this rifle would have feeding issues. The inlet on this stock was done incorrect. So is this an inlet issue, the top inlet of the stock or the bottom inlet on this stock? Let's dive in a little closer and take a look at this. So because we established that the recoil lug and the interface with this flat right here were of the correct dimensions, I don't think it's the top part of this inlet. If we had an issue with the recoil lug, or either this was not inlet deep enough or the recoil lug slot was not inlet deep enough, that would be a problem with the top inlet. The issue is with the bottom, and this is normally what we see. And the reason why is because this is supposed to be cut at a 3-degree angle. And as I look at this particular stock, I see a very common error. And it's interesting because I've never seen it with this particular manufacturer before. We've used a lot of these stocks and we've never seen this issue before. And hey, maybe someone was just having a bad day. They had a new machinist. They just didn't train someone correctly. It just happens. But here's what's going on. This is supposed to be cut at a 3-degree angle. I can visually see that this is parallel to the action inlet, and the front here is parallel to the action inlet. And then what they did was they just ramped their end mill from one flat to the next flat here. So instead of setting this up at a 3-degree angle in their machine, it is much easier to just have this on a rotary device, that you machine everything flat, and then you just rotate the stock and you machine everything flat. Unfortunately, this causes issues with the end user. Now, most of these guns are put together by gunsmiths. A gunsmith would look at this and go, I know what to do. I can fix this for my customer, and the customer's none the wiser. But when you're in a DIY situation, a problem like this can be very frustrating. So there's a few different solutions. We can contact the manufacturer, have them make us a new stock, might have to wait another 6-12 weeks, maybe even longer for a new stock. We might have the manufacturer might have the capability to fix this inlet issue. That might have its own timeline on there. If you're handy and you know how this works and how to fix it, I'm not going to give instructions on how to fix it on YouTube because the overlords don't like it. But you could do this yourself, or you hire a gunsmith, and your gunsmith is going to go in and repair your inlet. And we've done this many times for friends and our own builds. And I can say it's a lot of work. And so this is a situation where this particular stock was the most expensive part of this build, and the part that I was really hoping to not have a problem with. But we've identified the problem. Now we just need to fix it so I can go and get some trigger time